All right, class. So Mr. Miles here, and unfortunately, we can't have circle time today. So we want to be going through lesson 14 with you this way. So lesson 14 is about conditionals, and a conditional is basically an if-then statement. So if this, then simply this. If this expression is true, this is what we want to happen. If this expression is false, this is what we want to happen. All right, so for level one, we're going to make a prediction. You'll see that we've got two variables, sprite 1 and sprite 2. All right, and there's no animation at all. So we won't see any characters on the screen. Now, if you look at lines 5, 6, and 7, we've got some new code, and that new code is console.log. And basically, that particular code is just going to write text. It's going to write text in the debug console area. And it's going to write either true or false based on the expression, which is in the orange. The first expression says sprite 1 y is equal to sprite 2 y. Right? And if that is true, it's going to read true in the debug console area. If it's false, it's going to say false. So what we can do, we're going to look at sprite 1, sprite 2y. So sprite 1y is 200 and sprite 2y is 200. Are they equal? Yes. So that expression is true. All right, so in the debug console here, it's going to say true whenever we run the code. Now for the second expression, it says sprite 1x is greater than sprite 2x. Sprite 1x is 100 and sprite 2x is 300. So is that expression true? No, it isn't. So that's going to be false. And the third expression says sprite 1x is less than sprite 2y. So sprite 1x is 100 and sprite 2x is 200. So is that true? It is. All right, so in your prediction, you're going to write, not write, but we have to select what we think the debug console is going to present to it. So we've seen that the first expression is true, the second expression is false, and the third expression is true. So the correct answer would be C. All right, and there's our two sprites. And in the debug console, you see that we get these three messages. So we're finished here. Let's move on to level 2. Two is part of our warm-up. So whenever you get a chance, which you should have already done it, you're going to watch the video, answer these 3 questions, and submit them in Canvas. Let's go to level 3. All right, so for level 3, what we're going to do, we're going to read these descriptions here, and we have to match them with the Boolean expression. All right, so it's a good idea to have an understanding of what these symbols represent. First description says, is the dog sprite rotation less than the cat sprite's rotation? So we're dealing with rotation here, and just by a process of elimination, we can see that this is the only code that has to do with rotation. So dog rotation less than cat rotation. Second description says, is the dog sprite X less than the cat sprite X? So we got dog dot X less than Right, so our less than symbol is this one here, right? And our greater than symbol is here. So to determine the difference between the two, it all depends on which side of that symbol is open. If it's open to the left, that means greater than. So the alligator is going to eat. The alligator is going to eat the greater value on the left. And if it's less than, it's going to be the opposite. That's just something that I remember from grade school. All right, is it dog sprite scale greater than? All right, so we only got one expression here dealing with scale. All right, and that's our greater than symbol. So remember, the alligator is going to eat the greater value to the left. Is it dog sprite x greater than? All right, so sprite x greater than and equal to. So for the equals, it's 2 equal sign and not 1. So we're going to omit that and move on to level 4. All right, so in level 4, we have a race car and finish line animation. So what's happening is the race car is traveling across the x-axis, and once it gets across the finish line, we want the debug console to recognize that it crosses the finish line. And to do that, we have to write an expression. All right, so in our code, underneath the counter pattern here, we're going to add a console dialog, and the message that we want it to present is this here. So in our instruction, you can see that we want it to ask, is the x position of the race car less than the x position of the finish line? So we have to grab our less than expression, and we're going to put it where it says message. All right, and since we're dealing with the x axis, we want to grab sprite.x. So if race car dot x is less than finish line dot x. All right, and make sure you spell everything correctly, or copy and paste right here. All right, because if you don't type it correctly, it won't work correctly. All right, so now that we have this expression and we run the code, you'll see that in the debug console, it's going to read false until the car crosses the finish line. All right, once the car crosses the finish line, it's going to say true. All right, because as long as the race car is greater than the x position on the x-axis, it's going to be false. But once it crosses that x position of the finish line, it's going to read true. All right, so we are move on to level 5. Now, in level 5, this is going to be our first if statement that we're going to write. Or actually, we don't have to write the if statement. We have to read the code, and we have to predict what the if statement is going to do. Okay, so let's read the code. And this is the same animation from before, except this time we're using this line of code. So it says if racecar.x is less than 100, it's going to display the word winner the debug console. All right, so that's exactly what's going to happen. So once the race car crosses the finish line, it's going to give us this message in the debug console. Just leave it there. And as long as the race car has a X value less than 100, it's going to always say winner. So that's what we have to write in our prediction. So I'll finish here. Let's move on to level 6. Video where you watch about if statements. Okay, so we're not going to do this here. So let's move on to level 7. And in level 7, what we're going to do is we're going to write our first if statement together. Okay. And according to our instruction, it says that we have to use a condition in the draw to check that the fruit scale is greater than 2. And if it is greater than 2, we're going to change the fruit animation to a hair. Okay. Alright, so grab the if statement. We're going to bring it to our draw loop, and it says if fruit.scale is greater than. So in our math toolbox, we got to grab a greater than operator, and since we're dealing with scale, we're going to grab fruit.scale or sprite.scale, name it fruit, and if it's greater than 2, it says if the scale is greater than 2, we want to change the fruit animation. So we're going to grab our sprite.set animation. All right, the sprite that we're changing is fruit, and the animation is going to change to a pear. All right, so it's going to be an apple all the way up until it reaches size 2, and then it changes. All right, so we're all finished here. So we're going to level 8. So 8A. All right, 8A is pretty technical. So make sure you're paying close attention as we complete this level. All right, so for this level, what we have to do is we have to read through the code, read through the program, and we're going to evaluate Sprite 2 and its properties. So it's X and Y values, its scale, and so on and so forth. And we have to change the code so that each of the statements, each of the comparisons, right? So I'll show you the comparisons. So the comparisons are here. So we got 5 different comparisons, 14 through 18. And we want them all to read true, right? But if you notice, they all read false. So there's some changes we have to make to these expressions in order for them to read true. All right, so let's start with comparison 1. So comparison 1 says sprite2.x must be equal to sprite2.y. All right, so if we go to sprite 2, let's look at the x value. It has a value of 300, y has a value of 200. All right, and they should be equal. So it doesn't matter what the number is, they should be equal. So I'm going to make them both 200. And if we reset and run our code, you'll see that comparison 1 is now true. So for comparison 2, comparison 2 says sprite 2 dot rotation must be less than 40. All right, so let's go to sprite 2, and sprite 2 dot rotation is 40. I mean, it's 60, but it should be less than 40. So we can do 39. And if we run the code, we'll see that comparison 2 is now true. All right, so let's check out comparison 3. Comparison 3 says sprite 1 dot scale must be equal to sprite 2 dot scale. All right, so sprite 1 scale is 1.5 and sprite 2 scale is 0, and they have to be equal. So I'm going to make them both 0.5. And so reset and run. Comparison 3 is now true. Now for comparison 4, it says sprite 1 dot x must be greater than 150. Sprite 1x must be greater than 150. Sprite 1x is 100. So to make it greater than 150, to make it greater than 150, I'll make it 151. All right, so reset and run. All right, comparison 4 is now true. Now for comparison 5, comparison 5 says sprite 2 dot y should be less than 200. Sprite 2y should be less than 200. All right, so sprite 2y less. I'll make it 100 and okay. We run our code. See that comparison 5 is not true, but comparison 1 is false. So let's go back and check and see what comparison 1 has to be. For comparison 1, it says that sprite 2x must be equal to sprite 2y, right? And sprite 2y must also be less than 150. So we have to change the x value to match the y. And we're going to reset 1, right? That's what we ended up with. And we'll see that all of our comparisons are true. So we're all finished. All right, let's check out B. All right, so for 8B, it says the soup should spill out of the bowl when it turns upside down. All right, so to complete this, we must have an understanding of degrees and a circle. All right, so at the beginning, the bowl, while it's right side up, has a degree of 0. And when it's upside down, it will have a degree of 180. So once the bowl reaches 180 degrees, we want animation to be an empty bowl. So let's start with the if statement, and we're going to add it to our draw loop. Okay, and the rotation has to be greater than 180 for the bowl to be empty. So we want to find our greater than equation, expression, operator, however you want to refer to it. And since we're dealing with rotation, we want to add our sprite dot rotation. The name of our sprite is soup, and we want it to be greater than a 180. Although, realistically, the soup would spill long before 180 degrees. I think it would spill, it would be less than 90 degrees before it would spill, but that's besides the point. So upside down is 180 degrees. And at this moment, we want to change the animation to the empty bowl. All right, so the empty bowl has the name of bowl. Cool. All right, so run it. And it's empty at that point there. All right, let's do it again. So we got soup, and no more soup. Just like that. Moving on to 8C. All right, so for 8C, we have to make the alien dance when the spaceship reaches the top of the screen. Now, why the alien would dance once the spaceship leaves, I don't know. All right, but let's run the program and see how it works. All right, so the spaceship is flying up the screen and the alien should dance. So we have to add a conditional to detect when the spaceship is in the sky. And once the spaceship is in the sky, we have to make the alien dance by changing its animation. So grab your if statement, and since the spaceship is going up the screen, we have to detect its Y value. And since it's going up, and as the sprite goes up the screen, the Y value is decreasing. So we want to use less than. So if sprite.y, right, and the name of the sprite is going to be name of the sprite is we gotta fix that. Name of the sprite is spaceship. Spaceship.y is less than any point at the top of the screen. So let's say 50. So notice 50. Then we're going to set the sprite animation to set the alien animation to alien dance. All right, so reset and run. Once it reaches that point, the alien is going to do its thing. All right, so we're all finished there. Moving on to level 9. So in level 9, it says that we have to make the dinosaur turn into a pterodactyl when it reaches the sky. All right, so let's run the code to see what happens. All right, for some reason, we got a flying dinosaur. All right, and when it reaches the sky, or at some point in the sky, it's going to turn to a pterodactyl. So let's add some code. So we're going to grab our if statement, and since we're dealing with elevation up and down, this is going to be less than, and we have to detect the sprite's Y position. So sprite.y or dinosaur.y, to be more specific, is less than, we'll say, 150. So 150, we're going to change the animation, dinosaur animation, to the pterodactyl. All right, so run it, and there we have it. So once it reaches 150, it turns to the pterodactyl. We're all done here. Moving on to level 10. All right, so 10A. 10A. Yep, level 10A is pretty technical. So here's what we have to do. It says that we have to make the balloon pop when it reaches the edge of the game area. All right, and we really don't know at what point that would be. So in order to figure that out, we have to use a watcher on balloon scale to help us figure that out. All right, so the watcher is here in this location, and it says we have to type balloon scale. So we're going to add it. So doing this, we're able to see at which point will the balloon reach the edge of the game area. It's going to count up, it's going to count up, and really, it's moving at a slow rate. So I'm going to speed that up. That's wrong. All right, so 0.0. That might be a little too fast. All right, so let's see. So let's just say at a scale of 1, we want the balloon to pop. So if we check out our animation, there's our pop animation. So we can say if balloon dot scale greater than dot scale is greater than 1. Want to set the animation, set the balloon animation to pop. Okay. We'll notice that the pop continues to grow also. Okay, so since the pop animation is growing and that's not what we want to do, we'll have to readjust our code. All right, and according to our instructions, we have to create a pop sprite that uses the pop animation. Let's do that. So we're going to grab a variable, pop, and we want to set pop animation to pop. Also, in our instructions, it says that we're going to use the visible property to keep the pop sprite hidden at the beginning. So we don't want this to be visible. So we'll grab sprite visible, we'll name it pop, and for it to be invisible, we're going to type false. Right? So it's there, but it won't be visible until after the balloon scale reaches a certain point. So we don't need the set animation anymore. Instead, we want to use sprite.visible. And we want pop.visible to be true once the balloon scale is greater than 1. So run the code, and you have it, but just that the balloon is still there. We want to want the balloon to go away once the top appears. So we have to make the balloon visible false at this point. Alright, and according to our instruction, those are the two statements that we need. So we need a divisible property to hide the balloon, and we need the divisible property to show the top. So let's run the code, and there we have it, all done.